Hey, how you doing? My name's Elton. Thank you for joining me. This is Learn Docker in a Month of Lunches. It's the serialization of my new book, which is available right now. You can get a copy on Amazon or from the Manning website. And the whole purpose of this book is to help you learn Docker, whether you're a complete beginner or whether you've used Docker in the past and you want to learn the real principles behind how everything works and get the best practices kind of baked in right from the beginning. So each chapter of the book is really task focused. There are lots and lots of exercises for you to try and to get familiar with using Docker. And the purpose of this YouTube series is to show you what you can do with Docker, to guide you through the book. But if you don't want to buy the book, like that's fine. You can just watch all the videos, all the source codes up on GitHub. It's all there as a useful resource, hopefully to help you get started with Docker. Okay, so let's see what we're going to talk about today. So let me push this button here. So this is the very first episode. It's slightly different from the others because I'm going to go through two chapters today. First of all, I'll talk about what we're doing in the series, what it's all about, what this book means, and who it's for. Then I'll look at two of the chapters. The very first one is it kind of gets you up and running. It installs Docker, tells you why Docker is useful. I'm going to kind of skim through that because you're going to read that before you get stuck in. Really, it's quite a short chapter. I'll just focus on some of the major use cases of Docker. The bulk of today's session is all going to be about chapter 2, which is called Understanding Docker and Running Hello World. So it's the real basics of using containers, what a container looks like, how you get up and running with Docker, what it means to run your application inside a container using Docker. And then at the end, it's going to be Q&A. So if you've seen me present before, like if you've seen I've got a lot of courses on Pluralsight, like that's all super scripted, super polished, super edited. This is nothing like that. So these sessions are kind of unscripted, unplugged. They're going to be very informal. So I'm expecting to be sort of 45 minutes to an hour. If you've got questions to ask, then there's a Slack channel, which I'll point you to in a second. Feel free to ask questions in there, and then I'll pick them up towards the end. If there's anything interesting to talk about, I'll talk about it towards the end. Okay, so let's get going. So the first thing I'm going to do is at the bottom of your screen, you will see a link to diamol.net. So https diamol.net. So that's Docker in a month of lunches. That's the homepage for the site. When you browse, you'll see this. Let me switch to this view here, which is my full screen view. So this is the homepage for the book. So here you'll get the links to buy it on Amazon. To get the physical copy, you can go to Manning and get the digital copy to download. They also have a thing where you can go and read something like 5 minutes a day without paying for it. So you can kind of read the whole book on Manning. All the source code, all the Docker files, which are how you package things up. All that stuff's on GitHub. So you can explore everything there. And then there's also, you're going to find the links here to the Slack channel, which is where you can ask questions that I'll pick up during the stream. This is the link to the next stream that's coming. So that short link will always take you to the next scheduled stream, which will be today is episode 1. And there's also a giveaway. So I'm going to be doing this throughout. If you're watching live, I'm going to be doing this all throughout September this year. I'm going to do a chapter every weekday, which is kind of how the book is supposed to be read. So I'll do a chapter every weekday, and each week I've got 5 copies to give away. So if you go to that giveaway link, you just put in your email address. There's no spam or anything weird. If you win, you'll get an email with a link to go and redeem a copy of the book. And then there's some stuff in there about all the usual stuff to try and pitch the book. So that's your key resource. Remember that. If you remember nothing else, diamol.net will take you here, and from there you can head on to everything else for the rest of the book. Okay, so let's get started. So that's enough of the kind of intro. Oh, I do need to say hello to my son who is watching. It's beyond his bedtime, so watch for the first 10 minutes, and then like if it gets boring, then you go to bed. Like not everybody else. That's just for you, son. Okay, and I'll see you in the morning. All right, let's get to the book. So I'm going to open this in Visual Studio Code so we can do some. We can look at the examples as well. So this is what the book looks like. If you get it from Manning, you get the PDF as well. It's split into 4 sections. The whole month of lunches idea is a series. There's a whole bunch of different technologies that each have a month of lunches book. The idea is that every chapter is really focused on one particular task. It's very hands-on, so you do a lot of experience of using the technology, and it should take you about an hour to read and work through all the examples. So the idea being you spend an hour of your lunchtime, and then over the working month, you've got a good handle on the technology. And the real goal for the Docker book is to take you from zero or limited knowledge of Docker to the point where you're sufficiently confident that you'll be able to run your own proof of concept. You've got the skills, the tools, and the experience to know what you need to do with your own applications to go and package them up and run them in containers. So roughly into four sections, which are meant to be the weeks that you work through. Each section, there's usually 5 chapters, one for each weekday. But section 1 has got the kind of introductory chapter, and week 4 has got the kind of wrap up chapter. So those are fairly short. So I'm going to go through the first chapter here, which is before you begin. And this is really you're going to read this like in the bookshop, or you're going to read this the weekend before you get started. It's the introduction to why you use containers. So if you've heard all the hype about containers, and like for people who are new to containers, it's not a new technology. It's fairly young if you think about some of the technologies lifespans that have been out there, but it's kind of 6 years mature now. People have been using it for a very long time, and it's evolved very, very rapidly. So it's a really stable technology. If you're interested in the whole concept, but you can't really answer the question, why should we be investing in Docker, then this chapter's for you. There's a couple of things I'm just going to point out from this chapter before we get on to the more kind of practical stuff. So there was the Stack Overflow do this developer survey every year. And in 2019, which is when I was writing the book, Docker was voted the most wanted technology, like the number one of all technologies that people want to work with. Docker was number one. And in the 2020 survey, which has just come out, Docker's still number one. So there's a huge amount of interest from people who want to get learning the technology, and they don't always have the opportunity to do that at work, because it's as you'll see as we go through this month, it's quite a significant change from how people build and run applications in the current world to move over to containers. Now, the great thing about Docker is it's a really kind of lightweight technology. So you can run it on your laptop, on a Raspberry Pi. It's cross-platforms. You can run it on Linux, on Mac, on Windows. It kind of works the same way everywhere. And it's very kind of beginner friendly. You can pick it up and get up and running with it and get productive with it really quickly. But you can kind of find yourself, you do a bit of Googling and you get a Docker file and you package your application. But if you don't understand the principles behind it, you can get yourself in trouble later down the line. So that's what this book does. It breaks it down into the core principles, and gets best practices baked in from the start, so you know how this stuff really works. Okay, so I'm not going to go through this too much. This is all the kind of blurb about what people are doing. There's some stuff in here about why containers will take over the world, which is the main use cases why Docker and containers became so popular. And I'll point out the diagrams here more than anything. So the first one that I should give myself some background. I'm a Docker captain, which is the kind of community recognition for the Docker award. I'm also a Microsoft MVP. I worked for Docker for 3 years, and before and after that, I'm a consultant. So I've been consulting with companies doing big projects. And a lot of what people have been doing for a long time is looking at their existing application landscape and wondering how they move that to the cloud or to a new platform. And containers offer a really interesting option there. So if you look at this diagram here, what we've got at the top is the kind of the current state, which is I've got a whole bunch of things that are running on different virtual machines, either in my data center or in a hosted environment somewhere. And what I want to get to is run these things in the cloud, so I get all the benefit of planet scale, only paying for what I use, all that sort of stuff, like spinning things up super quick, all the benefits of the cloud that we've known about for the last decade. Now, the trouble is what people tend to do is they look at their chosen cloud, and often there is no choice of cloud because your company has an existing arrangement. And then they look at each component in their application stack and they map it onto the application, the product platform that you get with your cloud. So I've got this list of services that the cloud provide. I'm running MySQL in the data center. Well, there's a managed MySQL service. That's nice and easy. I'm running some sort of message queue. Well, there's a managed Redis service or whatever. So you do this kind of mapping exercise that says, I've got these things now, and I'm going to use these cloud services to replicate my application. The problem with that is like you get all the benefits of the cloud, but it's a project to move your app, and it's a project to move every app, and you've only moved it to a single cloud. So if further down the line you want to move from AWS to Azure, which people genuinely do, I've had an 18-month project that did exactly that. you've got another project to migrate everything again to the different set of services. So what Docker gives you, what containers give you, is this alternative here where you take your existing components and you containerize them. So you package them up so they'll run in Docker, and then you can run them anywhere. And that container that runs your application, we'll see what that looks like very shortly. That container works in the same way on your laptop, in the data center, and in the cloud. So you can move things around really easily and between clouds too. So it gives you this kind of layer of consistency, which means that when you migrate to Docker, which does still involve effort, that's hopefully the last migration you do. Because when your app is running in Docker, then you can kind of run it anywhere. So the first thing that people are doing is migrating to the cloud. The second thing is I've got these applications that are running in the cloud. Some of them are maybe 10, 15 years old. It would be nice to really get the benefit of all the cloud stuff, being able to spin up dozens of instances really quickly to deal with load and to auto scale and all that sort of stuff. And your big monolithic applications can't really benefit from that. So what you can do is once you've got something running in containers, that's what this diagram here shows, the box in the middle, let me see if I can remember the right buttons. The box in the middle here, that's my existing legacy app, my big monolithic application. You can put your monolith in a container. You don't need to change any code. It'll just work in the same way. It's all fine. You can do that. You don't get all the benefits of containers, but it'll get you up onto the cloud if that's what you want to do. But then you can start breaking features out. So you can be breaking out new features and running them in new containers. And they are small microservice architectures that do let you take that old application and gradually break it apart. So you're not throwing away the whole thing and starting from scratch, which is a 2-year project. You're just as you approach each new feature, as you approach each section of the application, you break it out into separate containers and you just wire them all together with Docker. And that's a really nice way of approaching that modernization piece. And the flip side of that is having a completely new application. And if you've heard of the microservice architecture, it's really popular and it's become kind of synonymous with containers, which is not strictly correct because, as I've said, you can run a big monolithic app in a container just fine. You don't have to have a microservice architecture to run containers. Similarly, you don't have to use containers to get microservices. There are other ways to run small components in a distributed way, but they do work really nicely together. So because containers are these small, lightweight components, you can spin up super fast. You can distribute them across multiple machines really easily. They fit very nicely with a microservice architecture like this one here, which is from a GitHub repo that Weaveworks do, who are a company in the Kubernetes space. And this is an example where every single component runs in a separate container. It has its own database. It owns its data, all that sort of stuff. All the new modern architecture, all powered by containers. And the last thing that I'm going to kind of cover here is when you're looking at technical innovation. So containers aren't the end, the other things will eventually come. One of the things that's coming down the line is serverless, the ability to just bring your code to a platform and have it run it for you without having to worry about compiling it and building it and packaging it and distributing it and configuring it. It's just a serverless function is a super nice way for certain use cases. It works really well. But again, you get the trouble of Azure functions are superb technology, but it only works with Azure, and AWS Lambda the same. You can't really move them around. And if you're running a whole bunch of your older applications across containers, it's kind of nice if you can just have one platform, and you can run serverless applications inside your containers. So you get a very similar workflow. You run you send your code to the cluster, which is just a bunch of machines that run your containers, and it spins them up and it builds them and packages them and runs your functions when they get invoked by an HTTP request or whatever. So you can get that same kind of workflow. So new technology that comes down the line is taking advantage of containers. So by learning your way around Docker, you're kind of future-proofing yourself to a certain degree. Okay, so there's a whole bunch more stuff in chapter 1, which is the kind of get you up and running with containers, understand why it's useful. But what I'm going to do here is go down to section 1.3, which is about setting up your lab environment. So when you're installing Docker, you're going to do this to kind of run through all the examples in the book. So the expectation is that you've got Docker installed and you're going to follow the examples. Not necessarily every one. There's usually 10 or 12 per chapter. But the idea is you'll follow along and you get a lot more use out of the book by doing that. You get a lot more experience of using Docker. You get familiarity with the commands. Everything will work, obviously, because it's all been tested. But if something did go wrong, you'll get some experience in debugging and finding all that stuff out. And the important thing about this book is every single example should work across all of those platforms that I talked about. So Mac, Linux, Windows, Raspberry Pi, whatever you can install Docker on, with the exception of IBM mainframes, because I don't have one of those, so I can't build my applications to run on that. With the exception of that, you should be up and running and be able to do everything that I do in this book. So any technology you've got, you can use to follow along. And I'm trying to be really careful not to have too many assumptions about where you come from in the technology world. So hopefully, whatever your background, whether it's devs or ops or architecture or whatever, this should all kind of make sense for you, and hopefully it'll fit into wherever you're going in your journey. So I'm not going to follow you through this, but this is how you do it. The best way to install Docker is to run Docker Desktop, which is just a link there on Windows or Mac. If you don't have the recent-ish versions of Windows and Mac, you can use Docker Toolbox, which is an older technology. If you're running on Linux, then you can install it directly. So Docker Desktop, the best option. If you can't do that, then this section of the book takes you through the other options you can do. And when you've got it up and installed, let me get rid of this and open my terminal. So when you've got it up and installed, all you're going to do is run Docker version to make sure that everything's up and running. And that will print out a whole bunch of stuff, which you don't necessarily need to dig into just yet. But as long as you can see something coming out, then that means you've got Docker installed. I've got the latest version here. I was running an older version when I wrote the book. And there's another component of Docker called Docker Compose. So we'll deal with all this in a great amount of detail during the next month. But just so you're up and running, you've got everything that you need. If you get a result from Docker version and Docker Compose version, then you're good to go. Okay, so the next thing you need is all the source code, but I've already got that. So I'm going to switch now to chapter 2. And this is going to be the bulk of today's episode. So understanding Docker and running Hello World. So let me close my terminal and we'll start by reading through this. So zoom down a little bit. Okay, so it's time to get hands-on with Docker. So in this chapter, the idea is you're going to just start using it straight away. So it's very practical focused, this book. You run lots of exercises, and then when there's theory about how things fit together, it tends to come after the exercise. So you see how it works, you see why it's useful, and then we start digging into how it works. So the first thing we're going to do is we're just going to run a container. So I've got Docker installed. Docker is the tool that you use to run your applications. So an application gets packaged in a way that lets it run in a container, and that package has a name. So I'm going to run this package here. So this is Docker container run, which is the command. Whenever you run an app in a container, you're interacting with the Docker command line. Let me zoom this back in again now. Okay, so the Docker command line is how you manage your applications, which are running in containers. So if I follow this, paste this in here, I'm saying Docker container run, which basically means start me a new application in a container. And the name of the application is DIAMOL / CHO2 hello DIAMOL, which is an application package that I've put together. I've made it publicly available. So anyone with Docker installed can run this command, and you should get a similar output to what I'm about to get here. Now, I'm doing this kind of giving you as an authentic experience as possible. So I don't currently have that application package on my machine. So it says, Docker says it's unable to find the image. Images are what these packages are called. So it downloads the image, which it calls pulling. When the image is downloaded, then it runs the container, runs the application that's in that package. And all this application does is it runs a script that prints out a bunch of text. So it says hello so this is the output from running my container. It says hello from chapter 2. It gives me the host name of the computer, which is a fake host name. It tells me the operating system that it's running on, which is Linux. I'm running on Windows 10, but Docker Desktop supports Linux containers too. And it gives me the IP address that the container sees. Okay, so you'll get a better feeling for what all that means by the end of today's session. But just to give you a feel of like how simple it is, that could be doing anything inside that container. You know, I could have someone package up an application image that runs a script that deploys a whole bunch of stuff in the cloud, or runs a whole bunch of tests, or anything. And all I need to do is do a Docker container run. And as long as that application image is set up in a way that it's easy to use, it will just work in the same way on my machine. It'll do everything that it's kind of scripted to do. Okay, so what happened there is we saw that the book here, what you see on the left here, every exercise has a screenshot that accompanies it to tell you what happened. So if you do have any problems, you can go and look at the screenshot and say, well, I see there's something slightly different from what I did, just to kind of help you point it out, and pointing out all the kind of main things there. So I've walked through all this just now. The run command starts my container. I didn't have that package, so Docker downloaded it. It's on a publicly available location, and then it ran the application container and gave me the output. So fairly straightforward, fairly simple. So the DIAMOL bit is the name of the name of the book, and that's where Docker goes to look for all these images. Okay, so this is the output. The output's going to be slightly different depending on the system you're running on. So if you're running Windows containers, then you'll see something like I'm running on Microsoft Windows as opposed to I'm running on Linux, which I got when I was running. If you're running on a Raspberry Pi, you'll see something slightly different again because it includes the type of the CPU. So rather than being like on my output, I've got my Intel chip. So it's an x64, 64-bit Intel CPU. If you're running on a Raspberry Pi, you'll see something slightly different. But the whole workflow will be the same. You'll use the same command to run the container. The container will do the same thing, which is to run a script, but the output is slightly different depending on your operating system and the CPU that you're running on. Okay, so this is the kind of the core thing here. So anyone who can access this container image, this application package called DIAMOL, CH02, hello DIAMOL, anyone who's got access to that, which is everyone because it's public, will get the same experience when they run the application. So this is what Docker's used to call it build, ship, and run, and now they call it build, share, and run because it's sharing is more community focused. Someone packages their application up and they share it and make it available either to the whole world or to your people in your organization or your enterprise. Anyone who's got access can run the application in a container and they'll have the same experience, whether they're running it on their laptop or in a cluster in the cloud. So it's that kind of consistent approach to getting your applications running that containers give you. So now if I run the same thing again, so let's clear this down. I'm going to run exactly the same command. Let's make this bigger again. I'm going to make this smaller and this bigger. That's what we need to do. Okay, so I'm repeating the same command with the same container image. Now, I'm going to get the same experience, but a slightly different output. It didn't download the image, the application package, because it's already on my machine. So Docker will reuse that container image and just start a new container from that image. So if you're from an ops background, it's kind of like having a virtual machine image and starting a VM from it. If you're from a dev background, it's kind of like the image is the class and a container is an instance of the class. So you can start multiple containers from the same image. I get a slightly different output this time. So I get a different name of the machine. I get a different IP address. I still get the same operating system because that hasn't changed. But the host name and the IP address, they're provided by Docker. So what you get when you run your application container is you get a virtual environment that Docker creates for you. That's what the container is. So there's this line here. I was going to say there's a great line, but I shouldn't say that because it's my book. There's a line here that says, think of containers like a box with an application in it. So inside the box, the application sees a computer. It has a host name. It has an IP address. It can connect to the network. It can do all the usual things. It has a disk. But that stuff's all virtual and it's all created by Docker. So Docker provides that, provides the disk, provides the IP address, provides the host name. It provides that virtualized environment. So it's kind of like a VM, except that Docker is super lightweight because the process that runs the application, which in this case is just that little script, that runs directly on the machine. So there is no kind of big operating system layer in between. So the container itself uses the operating system of the machine where you're running Docker. So it's super lightweight. That's why containers are so fast. That's why they take up very little overhead to run lots of containers on one machine. Okay, so we've got a little diagram here that shows you that. So if I were to run multiple containers, they each have their own isolated environment. So my app one in the blue box, that has a host name and IP address, and it sees a disk, which are totally different from application 2. So my green container over there, it has a different host name, random host name, different IP address, and a different disk. But they're all running on one computer, which has its own host name, IP address, and disk. And they're all being shared by Docker. So typically in a production environment, I have my operating system, Linux or Windows. I install Docker. I don't install anything else. Everything else runs in containers on top of Docker. So if I'm running .NET applications or Java or whatever, I don't install those on the machine. They come in the container package in the image, and each container has got everything it needs, and they're all isolated from each other. So that's the whole idea of containers, is that they fix the problem of density versus isolation. So the idea of density is I've got a certain amount of compute power that I've paid for in some way or another, either by buying kit or by renting it in the cloud. I've got a certain amount of compute available to me. I want to run as many applications as I can on that compute because it gives me the best value for money. But some of those applications might interfere with each other. So if I've got different versions of Java running different applications, I can't necessarily just install loads of versions of Java on that machine and hope that they don't interfere with each other. Or I can't necessarily run an application that was built for Java 8 on a Java 11 runtime and hope that it works. What I want is isolation. I want each of those apps to have the dependencies that it needs isolated from everything else. And that's what containers give you. So the application image has got everything the app needs to run. And then the containers, when they run, they're super lightweight and they don't interfere with each other. So that's the kind of big benefit you get. And then this is the comparison to virtual machines, which you see a lot because it kind of helps people understand the context, although it's like not that useful a comparison really. But if I was to run those same applications, my blue app 1 and my green app 2 in virtual machines, then I would have my operating system, and on top of my operating system, I'd have a hypervisor, Hyper-V or Zen or whatever you're using for your hypervisor. And then each application would run in a virtual machine, which has its own separate operating system. And then on top of the operating system, I've got the application library, the platform, Java, or whatever. I've got all the dependencies the app uses, the application binaries, the config, all that stuff. The things that I care about are the kind of small bit at the top, and all the rest of it, the operating system, which takes up 10 or 100 times more space than and compute power than the application itself. I don't care about that. The thing I care about is the application. So what Docker does is it gets rid of that duplicated operating system layer, and the application container process runs directly on the server with this kind of thin boundary around it, which is the container, and that's what Docker's managing for you. Okay, so I say you get typically 5 to 10 times as many containers as you would VMs, but there's not really a direct comparison. Like if I've got a big server that I can run 50 virtual machines on, I can probably run 500 containers on there, but there isn't a direct comparison because containers, you can have them all running so that they all use as much CPU and memory as they need. Without having a fixed allocation. So in theory, that same server could be running 500 containers 1 minute and 1,000 containers the next, and you can kind of scale up as much as you need. Okay, so the first thing we've done there is I just ran a container that did one thing and exited. So it printed out the output from that script, and then the container exited, and it was done. So that's how you would run like a batch process in a container. The application image has got everything the process needs. When you run it, it does its work and it ends. You can run containers in other ways too, and that's what's going to happen here. So let me clear this down. So I'm going to run the same kind of command, docker container run, but this time I've got some more flags. I've got the interactive flag and the TTY flag, and I'm running a different image. So the interactive flag means, and with combined interactive and TTY mean connect my terminal session that I'm running the command to the terminal session inside the container. So it's like connecting to a remote machine. It's conceptually the same as starting a virtual machine and then making an SSH connection to it or an RDP connection to it in the Windows world, but with a single command. So when I run this, it's going to create me a new container. I haven't got that image locally, but it's going to download it, and now I'm inside the container. So my my shell prompt there is from inside the container, not from my host machine. So I've switched from PowerShell to Bash because that's what the container is using. So now I've got my application container running. I'm connected to it, so it's like a remote connection. It happens to be a container, but as far as I'm concerned, it could be a remote machine in the cloud or anywhere. And again, what you see here will be slightly different depending on whether you're running on Linux or Windows, because the shell you get will depend on whether it's a Linux container or a Windows container. I'm running Linux, so I see a Bash shell. If I was running on Windows with Windows containers, I would see a command line shell. Okay, now if I run a couple of commands here, so if I run hostname, let's grab this here. I'm copying and pasting because otherwise, like, you'd see the pain of watching me type. So the hostname is the hostname that the container sees from inside. That's part of the environment that Docker constructs. So it's this random hostname. If I look at the date, then it's going to tell me the output in the format from the container, which is my host service date. So some of this stuff it gets shared from the host operating system. Some of it is unique for each container. Okay, so that experience is kind of just like doing a remote connection. Now, if I go and have a look at my containers, so I'm going to leave this running. I'm going to start a new session. And if I run docker container ls, that's listing me all the running containers. So if I do that here, I'll see I've got one container running, and the ID is this DA5652. And it also has a name. So the container name is Great Dijkstra. Now, Docker generates a random name for a container if you don't provide it with one. And you can also use the ID to refer to it. Now, if you want to work with your containers, you can use the ID, you can use the name, you can use the smallest part of the ID that uniquely identifies that container. So Docker container list is just showing me all the application containers I've got running. Docker doesn't care whether that container is doing some long running batch process or whether someone's connected to it in a different session. They're all just containers as far as Docker sees them. Now this name here, the container ID, is the same as the host name. So when Docker constructs this environment for the container to run in, it generates a random ID for the container, and it provides that inside the environment as the host name for the operating system. So inside the application, I would see this as my host name, which is obviously not a real host name. My real host name, let's see what it is. I'm going to type now. It's some random host name with naming convention for my data center here. Okay, so that's running it's separate from any other containers. I could run another container in an interactive mode on a different session. I get a different host name, different IP address, all that stuff. Okay, now if I go and have a look, the way I manage containers, the way I work with them is always through the Docker command line. And so most of the exercises you're going to see in this book start with the word Docker, because you're going to use Docker container run to run an application in a container, Docker container list to list my applications. Doesn't matter whether they're Java or .NET under the hood, doesn't matter whether Linux or Windows, the commands are all the same. The way that Docker interacts with those application containers is all the same. So if I go and run Docker container top, that shows me the applications that are running inside the container, the processes inside the container, but I have to name a container. So this is my DA56, and again, I don't need to do the whole thing. I just need to do enough for it to differentiate. And it tells me the command, the processes that are running inside my container. Again, this is Windows, so I've got the shell command. Sorry, it's Linux, so I've got the shell command. If it was a Windows container, I'd have a few other things in there as well. Linux containers share pretty much everything from the base operating system. Windows containers have a few of their own processes for each container. So if you're familiar with Windows, if you do the same command in Windows containers, you'll see a bunch of service hosts, Windows services, background services that run in each container. So you'll see a few more processes. But the way I work with them is the same. And if I repeat that command, but instead of doing top, I do logs, I'll see whatever the output is from the container. So I can see what I was doing in my interactive session. But if this was a batch process, I would see the logs from doing the processing. If it was a web server, I'd see the logs from people accessing the website. So the interaction, the way you work with these things is all the same. And again, that's another part of the consistency that containers give you. I can run these same things everywhere and I get the same kind of experience. And for all my applications, I'm using the same commands to start them, to interact with them, to see how they're performing, and to get the logs out to see what they're doing. Okay, so we're looking at basic stuff still, but this is the kind of core stuff to get you up and running with containers. Okay, and the last thing I'm going to do is get rid of that escape command there. So if I go and inspect the container, so I've done Docker container list to show me all the containers. I've done Docker container top to show me processes inside the container, and Docker container logs to show me the logs. The last thing I'm going to show is Docker container inspect, which gives you a whole ton of data about the virtual environment that Docker's created. The output's JSON, which is great for automating. So like all this stuff, you often see Docker in the context of DevOps because it's super easy to automate. So this idea of a pipeline that takes your code, packages it, runs it in a container, runs a bunch of tests. If everything passes, then it goes and pushes it to live. It's simplified with Docker because it's so automation heavy. It's easier to do automation in Docker than to manually create stuff. So it really lends itself to DevOps principles. So the output's JSON, there's a whole bunch of stuff in here. So there's some of the things that I would see from the outside too. So I can see the container IP address inside the container. If I look, that's the IP address I would see. I can see the gateway, which is how Docker owns the network the container is running. So Docker is managing that IP address. Docker is configuring how the network traffic goes to and from the container. There's a whole bunch of other things in here, including some of the configuration for how the container image is set up, and the host name and all those other bits and pieces. There's a lot of stuff in there, and you do use this for troubleshooting, but it's pretty handy to be able to dig into the diagnostics of how that container is set up. And again, this is the same for any type of container. So I could have my 10-year-old Java application on a Linux machine running in a Linux container, and my 10-year-old .NET app on a Windows Server machine, and I'm still using the Docker container commands to work with those applications. Okay, so let's skip down through here. So the more interesting thing we're going to do, so we've seen like running a container that runs a script and then ends, and running a container that you connect with interactively, which is really useful for kind of exploring and doing some kind of interactive testing. But mostly what you'll do is run a container that just sits there and does some stuff until you stop it. So web servers, databases, message queues, like back-end server processes that are pretty much just keep running until you upgrade them or replace them. So for that, the last thing we'll do here for today's episode is show you that by running a website. So we'll run a really simple website in a container. Now, first of all, we're going to look at the containers that we ran previously. So when I run docker container list, let's put this in here. I can see my container that's still up and running, my interactive container. If I add the all flag, so docker container list all, it shows me all the containers irrespective of their status. So the list command just shows you the kind of active containers, things that are running right now, whether they're interactive or not. The -- all flag shows you no matter what the status is. So I still get my Dijkstra here, which has been running for 7 minutes. That's the container ID there. The status is up, which means it's still there. There's a process still running inside the container, which means the container is still alive. The other two, which I ran first of all, those are the kind of hello DIAMOL, which just ran the script and ended. They're in the exited state, which means that they're not using any more compute power. So it's like having a VM that you've shut down. So it's not using memory, it's not using CPU, but the environment of the containers still exists. So the disk still exists. So if as part of that container running, it wrote a bunch of stuff to its virtual disk that Docker manages, that still exists even though the container's finished. So there's a really important thing here, which I'm gonna flip back to the text to make sure that I don't forget that. So firstly, the containers are only running as long as the application in the container is running. So the reason those hello DIAMOL containers are in the exited state is because they were configured to run that script when they start. The script prints out a load of text and then ends. And that process, when it finishes, the container finishes. So a container is just a wrapper around an application process. If the process ends, the container's gone with it. It goes into the exited state. It still exists, so you can still get to the disk and you can start it up again if you want to. You can still work with it in different ways, but it's not using any compute power. So I can have a whole bunch of containers that are doing nothing and they're not using CPU or memory. And then the second thing there is that they don't disappear. So I can still get the logs, I can still work with them, I can still do different things with them. Okay, so that's the thing that a lot of beginners don't quite understand when they start running their own applications, is they build their application package to run in a container. When they run the container, it starts and finishes, and they don't know why it isn't still running. And it's because they haven't configured it to start their process and make sure that process keeps on running. Okay, so let's go and look at a more useful example here, which is running a web application and running a website in my container. So I'm going to do docker container run. It's the same command, so it doesn't matter what type of container it is, whether it does some work and finishes, or whether it's interactive, or whether it's going to sit in the background, that you still interact with it in the same way. What's different are the flags. So instead of like the interactive flag, I've got the detach flag. Detach means start that container, put it in the background, keep it running. As long as the process is running, the container keeps running. The publish flag tells Docker that I want to allow network traffic into this container from the host. So by default, when you run your container inside your server or your laptop, network traffic can't get into that container unless you explicitly allow it. And what this does is it says the colon there, the number before the colon is the port that my machine is listening on, and the number after the colon is the port that the container is listening on. So when I run this container, there's a process running listening on port 80 inside the container. By publishing that port, Docker on my server or on my desktop is listening on port 8088, And when any traffic comes in on that port to the computer, it sends it into port 80 on the container. Okay, there's a diagram coming up where you'll see that in more detail. And then it's the name of the container package, the container image, which is hello DIAMOL web. Okay, so let's run this. Again, it doesn't have that image locally, so it'll download it. These are all super small images. They're tens of megabytes, so they get downloaded. And then it starts the container. The long number here is the full container ID, and the first 10 or 12 characters of that would be the host name that I would see inside the container. Okay, so if I run docker container list now, and we'll see I've got this new container running. So I've got my my original base container where I've got my interactive connection in my separate session, and here's my hello web container. It's up for 17 seconds, so it's just started. It shows me that there's this port open, so port 8080. Should have chosen a different port. Port 8088 on my server is going to be forwarded to port 80 on the container, and it's got a different random name, Vibrant Nightingale. Okay, so my web application is up and running. Now, those are the flags that I talked about. Detach puts that container in the background, so it doesn't connect to it like an interactive container, and it expects it to keep on running. And the publish is just about publishing the port, making network traffic from the host, the machine that's running the container, and sending it into the container. And here's that diagram that I talked about, just in case my wordy ad hoc description wasn't clear enough. So here's my computer is the gray box. It's listening on port 8088. Any traffic that comes in, Docker receives that traffic. So Docker interfaces with the networking layer of the containers and of the host machine, and it can join them together. And it's going to send traffic into port 80. So inside the container, the app is listening on port 80. It gets the request, and then it deals with it. Okay, so let's go and look at this. Now, if I browse to HTTP localhost on my machine, because I'm running Docker Desktop, the container is available on localhost. So I don't need to worry about where it gets routed to. So let's go and open a new tab, browse to this. Oh, that was good. So I told you it was live. There's a space there that shouldn't be there. Okay, and here it is. So here it is. So I'm a container consultant. I am not a web design consultant. So here's my web application. This is running inside my container. The container received the traffic when Docker forwarded it in there. The process inside the container is a web server. It's the Apache web server, and it just rendered this out, which is just static text. So it's just a simple HTML page inside my application container, which is also packaged with a web server. So it's pretty basic, but this could be, this could be Amazon.com running inside my container with a web server that's able to power it as well. Okay, so here's the screenshot, which shows you that I'm not faking it. It's pretty easy to fake, but it's easier to run it than to fake it. So it's pretty straightforward. But what it's giving me is the whole thing my application needs. So if I'm a web developer and I want to see how the application is going to look and run on the actual web server that we're using in production, then I can just run a container that's configured with the real web server. So I don't need to worry about installing Apache or making sure I've got the same version of Apache or IIS if I'm running on Windows or Nginx or whatever I'm using. That can be all set up for me in my container image, and I can just run it and see the whole thing working. Okay, so that's up and running. There's one last thing I'm going to show you, one container command. If I run docker container stats, that tells me how hard my container is working. And this one is 664. And it gives me actually I'm not sure how code's going to render this. Oh yeah, so I get this nice little flashing thing here. It's telling me how much memory it's using, how much it's allowed to use, how much CPU it's using, and how much network traffic there's been. So I'm seeing this is a fully fledged web server running in a Linux operating system. It's using like 6 megabytes of memory of the 26 gigabytes I've got available to it, and next to no CPU. So again, stats command works in the same way for any container. It'll just tell you how hard the container is working, what's going on inside that container from a compute point of view, from a memory and CPU point of view. So that's all up and running. I could, if I were to hammer this container with a whole bunch of web traffic, I would see those figures kind of spike. And again, I can use that for performance testing. So there's some, nice use cases for getting everything in one place, my web server and my content. Okay, so if I'm done with that, I can remove my container. I can do a docker container rm, which is going to remove the container. That will remove any containers that are stopped. If I want to remove containers that are still running, like my web application and my interactive container, I need the force flag. That's going to tell Docker, even if it's still running the process, kill it and get rid of the container. Now, here's a very useful command that you're going to use all the time. The $ and the brackets work for Linux and Windows and Mac shells. So all of these exercises that you're running should work in the same way, no matter what operating system you're using. Which made them very difficult for me to write, but should make it easy for you to use. So Docker container RM and force is, I'm going to forcibly remove a container, but then inside the command that's going to run there, the nested command is listing all containers. So what this is going to do is say list all containers and then remove them all. So it just clears everything down. Okay, so if I run that, I'll get a bunch of IDs coming out. At the end, those are the containers it's removed, and now I don't have anything left. So if I do a Docker container list now, let's put the all flag in there, then I've got nothing. So cleared everything down. Not only am I not using CPU and memory, I'm not using any disk anymore because those machines are all shut, those containers are all shut down. If I refresh this, which should have been coming from my container, I won't see anything now. It'll time out after X number of seconds because there's nothing listening on 8088 anymore. Docker is no longer managing the connection to take traffic from my host computer and send it into the container because there is no container. Okay, so that's the kind of the basics for getting started with Docker. So you've seen some of those, how those containers work. We've seen a container that runs and then ends. We've seen a container that you can interact with like a remote server. And you've seen a container that just sits there in the background, in this case, a web server that will just keep serving requests until it gets killed. Okay, so the end of this episode, the end of this chapter is a kind of a little bit of a deeper dive into what's going on there and the things that you've skipped over. I don't go into a ton of technical detail about how containers are built and how they're managed by the operating system and how Docker interfaces with the network and the disk and the CPU. There's another book by another Docker captain called Docker in Action, which goes into those lower level details. The focus of this book is really showing you what you can do with Docker. So I don't go into the internals too much, but I do show a couple of diagrams coming up here which show the main features of Docker, the main pieces of how all this stuff works together. So the first thing you need to understand is that there are two parts to Docker. When I ran the Docker version command, I'm going to do some typing here, so you have to forgive me. Docker version. There are two responses coming out. It tells me the version of the client, which is the command line, and the version of the server, which is the Docker engine that I'm connected to. So that's an important thing to realize. The engine itself is the thing that runs on your host, on your laptop or your server or your cloud VM. And that's the thing that manages the containers for you. It has a REST API, and the Docker command line connects to that REST API. So every time I run a Docker command, it's just sending requests to the API, and it happens to be the API that's on my local machine, but it needn't be. Like I can configure my Docker server to allow remote connections, and I can configure my Docker command line to talk to a remote server. So I can manage my cloud servers, my Docker machines that are running up in Azure from my local laptop with my same Docker commands, and they're kind of same everywhere. So the Docker engine is the thing that sits on top of your operating system. It runs as a daemon on Linux. It runs as a Windows service on Windows. And it's the thing that manages containers for you. And it's the thing that deals with requests from the API. The image cache is where those images are stored, those application packages. So now I've got a few images that have been downloaded as part of the exercises that I've done, and they live inside the cache. So every time I run a container now from one of those images, it comes from the cache. So Docker won't download it if it's already got a copy locally. So it's super efficient. And as you'll see, as the book goes on, as the series goes on, the way those images are constructed is itself super efficient. There's lots of sharing, there's lots of caching. It's a really nice way of structuring those application packages. Okay, so those things are all exist on the engine side. And the command line interface is just a client of the API. So API is a REST API. If you really want to, you can send HTTP requests from a browser or from curl to your Docker engine, and you can interact with containers that way. But obviously, the command line makes life a lot easier. Okay, so that's just kind of going through some of the structure of how Docker works. And the whole point of there being an API is it allows different ways of interacting with containers. So this screenshot here is showing you a different UI. There are a couple of different UIs for working with Docker. So there's an open source package called Portainer. There are commercial packages like this one, which is from Mirantis, who used to part of the Docker Enterprise suite. And you're still seeing the same information about containers, but you can represent it in a graphical way as well. Okay, so that's kind of the walkthrough of the session today, of the episode today, which is mostly focused on chapter 2. So we've run some containers, we've had a little bit of a look at the internals, the separation of the engine and the API. We've got a little bit of a feeling for some of the terminology, images and containers, and the consistency you get. So an image could have anything in there, and the way you work with containers is the same no matter what's happening inside those containers. Now, every chapter finishes with a lab. So as well as the try it now exercises, which you've just kind of run through for yourself, there's this is kind of guided exercise for you to do as the chapter's going along. But the chapter ends with a lab which isn't guided. So there's a task which is for you to complete with a couple of hints to get you up and running. So if you try this and you find it hard, then there's always a solution up on GitHub. So if you want to see how the lab pans out, then you can go and there's a README file for every lab and a sample solution that I've put together. But it's really useful for you to go through this, and it just kind of cements the concepts and the practices that we've gone through in the chapter. So you get a real good understanding for how these things fit together. So the lab here asks you to change the web application from the container that we've just run. I'm not going to go through it in today's session because you might want to go through that yourself. So there are a couple of hints there. All the chapters end with the lab, which kind of looks like this. Here's a task for you to do. Here are some hints, and then here's the sample solution up on GitHub if you get stuck. Okay, so let's have a look here. I'm just going to see if we've got any good stuff in the questions. We're a bit low on questions today, so that's cool. Okay, so what we're going to do is I'm going to wrap up now. Like I said, this is pretty informal. So my idea is they're going to last somewhere between 45 minutes and an hour. Kicking off again tomorrow, so same time tomorrow, which is 1900 UTC time. So that's different everywhere, but it's lunchtime somewhere, I guess. Tomorrow we're looking at chapter 3, which is building your own Docker images. So everything we've done so far, let me switch to the right thing here. Everything we've done so far has been images that I've built. So all those DIAMOL images are things that I've packaged up and I've made publicly available. What we're going to do tomorrow is dig into take a step backwards, see how you build those images yourself. And then those are the kind of the core building blocks. So we're still in the week 1 phase of the book is all about introducing the core concepts. We looked at containers today, we'll look at images tomorrow, and during the rest of the week, we'll get all the basic concepts down. So by the end of the week, you'll be really familiar with the core pieces of working with Docker. And again, I've said it a couple of times, with best practices baked in. So you're gonna see how people really use containers in practice and how to get the best of them. Okay, so thanks very much for watching. I hope you found this useful. If you're watching the repeat, then all the links in the diamol.net site are still live. So head to the giveaway link. There's usually giveaways at various times in the year. Go and sign up. You might win yourself a copy of the book. And if not, then you can always buy it on Amazon. I hope you found it useful. So my name's Elton. I'll see you again tomorrow, same time tomorrow, and we'll start looking at container images. Thanks very much.